introduction to some advanced optimization features with the workflow between Altair Feko and HyperStudy. So as Jehun mentioned, this is a typical antenna design optimization process in FICO. You first design or specify, provide the design variables to your design in FICO, and you build your initial design and perform an EM analysis, and then you run your optimization. Based on the optimization, there is a modification of the design, and that leads to your final design once the optimization is run. So here you're basically doing like or running an EM analysis or running a simulation model while optimizing. So when we are optimizing any antenna or optimizing basically any model in FICO, um, the optimization process, it involves selecting the best antenna design from all the feasible options that are available. However, what FICO does not provide is a significant insight into the antenna design. So we'll look into that in a moment. But in order to understand or look into depth into the antenna design, design exploration and machine learning can be very helpful, as they can give us some more insight into the behavior of antenna design. So for that purpose, we have a tool within Altair called HyperStudy. HyperStudy is a multidisciplinary design exploration tool that can also provide fit models, optimization studies, as well as stochastic studies. It can automate processes for parametric studies, and you can do optimization and robustness assessments. So beyond EM optimization, it is a software that can do multidisciplinary design exploration. And it also helps the users in understanding the data trends. The interface is very user intuitive, and it is integrated with HyperWorks. So it helps to access the technology. So some of the things that Altair HyperStudy can help us with is investigate relationships. Um, s- so what it can do is you can actually understand how each variables or each parameters that you have in your antenna design, how they are interrelated to each other. That can be investigated. You can make predictions on your model by creating a mathematical model in HyperStudy, and you can also identify best design by running different types of optimization studies, and also assess reliability in terms of stochastic analysis. So what we are going to look in this quick introduction is how you can build a machine learning model in HyperStudy that can run quicker optimizations, and which can also provide us more insight into the antenna design process. So on a higher level, the workflow is as follows. You build a model setup in CAD FICO. Now this model has to be a parametric model. So all of the design variables or all of the dimensions of the antenna that you create should be assigned in terms of variables. Once your model is ready, you run the FICO solver, and you open PostFICO. So in PostFICO, we have a macro that can extract the parameters from the FICO model directly into HyperStudy, so that you don't have to create the model from scratch in HyperStudy. And once that is done, you then uh, create your optimization model in HyperStudy. You set up like a fit model or a surrogate model for optimization. So a little bit into the details of it. So optimization using machine learning, and how you can specifically do antenna design optimization using machine learning. So once, as we mentioned, that our parametric model is ready in CAD FICO, we run the FICO solver and set up a new study in HyperStudy. So for setting up the study in HyperStudy, once you use the macro that is already present in PostFICO, it will populate all of the design variables. It will import all of the design variables into HyperStudy. Inside HyperStudy, you can look at design exploration. So this is the step where HyperStudy collects all the data from FICO that it requires in order to create a surrogate model or a fit model that behaves like your actual model. So you train the model using machine learning by providing uh, data points for the trained model. And once your model is trained, you can then perform optimization on the machine learning trained model. So what is the advantage of doing this process is that the optimization will be extremely fast compared to the optimization that you would do using a physical model in FICO. So here we have a quick example on a patch antenna. So let's say we want to optimize a simple rectangular patch antenna. The goal over here is to minimize the reflection coefficient at 3 gigahertz. And we want the patch antenna to resonate at exactly 3 gigahertz frequency using machine learning. So the antenna that we have over here is optimized by varying these four parameters here. So the patch length X and Y, the offset of the feed, as well as the substrate height. So these are the four parameters that we are working with or optimizing in order to minimize the reflection coefficient that we have at 3 gigahertz. So our first step, as I mentioned, is to create a parametric model in FICO. Very simple to do that. You create a couple of variables and then you call for those variables as you design your antenna. Once your antenna model is ready, you then run the FICO solver and plot the response in post FICO. So here we want to minimize the reflection coefficient or the S11, and which is why we have plotted the quantity in post FICO. So in post FICO, you would just save this post FICO session, and then from the application macro, you go to utilities and there is one option called optimize model in HyperStudy. So when you go for this option, which is to optimize your model in HyperStudy, HyperStudy will just grab all of the variables that you defined in FICO and it will populate the study and make it ready for HyperStudy. So here the antenna that we have is already having like a good reflection coefficient of about minus 17 dB. But let's see if we can minimize this further using HyperStudy and let's see what the process looks like in HyperStudy. So in HyperStudy, a couple of steps that are involved. First is to set up the machine learning project using the parameterized FICO model. This is automatically done, the first step of it. So in this step, there is initial data collection that is done. This is required to investigate the relationships for the parameter screening. So over here, it will just collect all of the data from FICO. The next step, and which is the main step, is to create like a design exploration study for data collection. This data collection is needed to build the mathematical model using machine learning. So over here, HyperStudy will run a couple of runs or couple of simulation runs using your FICO model. So let's say, for example, if we run 40 or 50 simulations just so that HyperStudy can collect data. So once enough data is collected, you can then set up a surrogate model. So what is a surrogate model? It's nothing but a mathematical model that is created by machine learning. So you're you're training your model to behave like your original model. This can be done um, by different algorithms. There is one called the fit automatically selected by training, or the FAST, the short form of the acronym of this method. So that will create a fit model for you. And once a fit model is created, or the mathematical model is created, it is very easy to run the optimization. This is an intelligent optimization using the mathematical model, and this optimization can run within a few seconds. So you can run like 100 or 200 simulations, because it's not using the simulation model, it's now using a mathematical model that you have trained uh, using machine learning. So for design exploration, you can do parameter screening in HyperStudy. For example, we have a Pareto chart which shows the effect of each variable on the antenna reflection coefficient. So for example, here I ran this model. The number of samples that I gave it was 40. So it ran like 40 FICO runs. And from those 40 FICO runs, it gave me um, which parameter or which variable has more impact on the antenna reflection coefficient. So how does this help the users? This can help you in deciding which parameters are not of significant importance to your study. So in further optimizations, or in further modifying or rectifying your antenna design, you can ignore those variables, and that can save you some design space as well as iterations. So in this particular model, for example, the length X of the patch had more of an impact on the reflection coefficient compared to the substrate height. And apart from that, so once your mathematical model is trained, the optimization that you run then is very fast. So here you can see that the number of evaluations that I ran this model for was 500, and that ran within a couple of seconds. Also on the right, we can look at the graph of the number of iterations that it took for my model to reach an optimum value. So around maybe the 11th or 12th iteration, my model had already reached an optimum value. But you can run this for as many number of evaluations as you want, since it hardly takes a couple of seconds. So you can save time. Instead of running your simulation model, you can just run the mathematical model for optimization. So apart from that, in HyperStudy, you can also perform like what if scenarios. You can modify the values of input variables to see their effect on the output response approximation. So for example, in this table on the top left, you see that we have our variables length X, Y, offset, and the substrate height. So you can just use this scroller and vary the values and look at how the response could possibly change. So instead of running those models and spending time behind the optimization like we would do in a normal FICO run, you can just vary the values over here and look at how the response or the output would be affected. So in this case, since our aim was to minimize the reflection coefficient, here we can see that we have a comparison of an unoptimized antenna, which is already giving like a good reflection coefficient of -17 dB, versus an optimized antenna using machine learning, which is giving a reflection coefficient of somewhere around -21 or -22. So in HyperStudy, you can also conduct like a verification of your optimized model. Now, let's say I have already created a surrogate model, a mathematical model from my simulation model, but I do not know if the mathematical model is accurate enough or not. So in this case, you can run like a verification study where HyperStudy will verify if your optimized model was as accurate as your original model. So here we ran like a quick optimization, and you can see that there's hardly like a very slight difference between the two, and there's a very good correlation between our original model and the optimized model. So these are some of the things that you can perform using HyperStudy, some more insight into your model, which can save you a lot of time. So a quick conclusion. Through this presentation, we saw like a workflow between FICO and HyperStudy, which makes it easy to use machine learning for optimization of EM problems. Antenna design optimization, it can of course be done using FICO. However, if you wanted to know more insight into the design of the antenna, that can be achieved using HyperStudy. And machine learning, it introduces data-driven optimization as opposed to simulation-driven optimization, which accelerates the whole design process. And that also accelerates your optimization runtime that would be required to run like a simulation model versus just a data-driven optimization model. So yeah, that's it from my side. Thank you for listening.